Aloha and welcome back to Maui Huliau Foundation's Climate Literacy Virtual Classroom. Now that you completed part 1, in part 2, we will be focusing on the growing amount of carbon dioxide in the Earth's atmosphere and how that is resulting in the Earth getting warmer. In part 1, we learned about the carbon cycle and how carbon moves and changes forms. Different carbon sources, including burning fossil fuels, largely contribute to CO2 in the atmosphere. The greenhouse effect is a natural process that warms the Earth's surface. When the sun's energy reaches the Earth's atmosphere, some of it is reflected back to space, and the rest is absorbed and re-radiated by greenhouse gases. The absorbed energy warms the atmosphere and the surface of the Earth. You might be more familiar with this process that happens in a greenhouse. Although greenhouse gases play a crucial role in keeping our planet's weather warm and stable, too much CO2 can impact and affect our planet, warming it too quickly. So what is a greenhouse gas? They are heat-trapping gases like carbon dioxide. Let's meet the family. Carbon dioxide, which you are familiar with, is the main gas from burning fossil fuels. Methane comes from cattle, rice production, natural gas, and coal mining. Water vapor is naturally occurring but traps heat. Nitrous oxide comes primarily from agriculture, fertilizers, and power plants. And ozone comes from cars and factories, and although it can protect us when found in the upper atmosphere, in the lower atmosphere it traps heat. So how much CO2 is too much? CO2 monitoring started at Mauna Loa by a scientist named Charles Keeling in 1956. The Keeling curve documents the recorded levels of carbon dioxide in our atmosphere. Atmospheric CO2 has increased 40% since we started burning fossil fuels in the mid-1700s, which is the Industrial Revolution. Over half of that increase happened in just the past 40 years, which you can see on this graph. Your main activity will focus on analyzing this graph. There are a number of CO2 monitoring stations throughout the world, including the one that is located on Mauna Loa, Hawaii. Now going back 800,000 years. Carbon dioxide levels today are much higher than at any point in at least the last 800,000 years. Modern humans, Homo sapiens, have only existed for around 200,000 years, meaning that CO2 levels and therefore the climate have been pretty stable for all of modern human evolution. It is true that Earth's climate and CO2 levels have changed in the past 4 billion years. We will talk more about that in Unit 3 when we learn about how scientists study Earth's past. In this unit, you will be completing 3 activities. The first activity will allow you to graph that atmospheric CO2 and analyze your Keeling curve. You will have 2 options to graph your data. 1, you can use the online program to enter your CO2 levels or data points and create your graph. Or 2, print out the data sheet and graph points on the graph provided. Then you'll create a trend line. A trend line is where you connect as many points as possible in your graph and analyze any patterns. The next 2 activities, you will learn about seasonal patterns and how CO2 changes from one season to another. Additional videos can be found in the materials folder for further learning about these concepts. After completing these activities, take part 2 quiz before moving on to part 3.